class, this is Mr. Morris. We are going to talk about reaction rates today. I hope you've already clicked the link at the top to watch this video. It introduces the idea of collision theory. If you haven't already, go ahead and do so now, please. Alright, so the video talked about collision theory, and the idea is that in order for a reaction to occur, we need to have enough energy, and the reactants have to collide in a certain way. Okay, so they need to have the right orientation, and they also have to be colliding with enough energy. If I wanted to make a reaction happen faster, there's a couple ways I could do that. Several ways, actually. But it all comes down to collision theory. I can increase the number of collisions. I can increase how forceful the collisions are, so how hard of a collision that they are, or I could change the orientation to make it more favorable. Those are the ways that we can change how quickly a reaction happens, if I wanted to make it happen more quickly. Let's talk about some ways in which we can do that. First of all, we could decrease the particle size. In other words, it's like crushing it into a powder. Decreasing the particle size actually increases the surface area. Think about a sugar cube. If you were to lay a sugar cube on a table and then crush it, it would spread out over a wider surface. You just increased the surface area. Instead of just being the sides of the cube, you exposed the air to all of the particles of sugar. We increase the surface area when we decrease the particle size, when we crush something. And if you were to increase the surface area, you would increase the number of collisions. And that's why we would increase the rate of a reaction if we increased the surface area of one of the reactants. There's a demo here. If you want to go ahead and pause the video and watch the demo now, you could. If not, make sure that you watch it before the end of class. I think you'll find these demos interesting. And also, they're really useful in understanding this stuff. All right, increasing the temperature does something else. Increasing the temperature actually increases the speed of the molecules. When you heat something up, the molecules move faster. Well, if they're moving faster, just think about if you were walking through the halls on a normal school year. You're walking through the halls. It's pretty busy. You're bumping shoulder to shoulder into different students. If you were to increase the speed at which you're doing that, instead of just walking through the halls, you're running through the halls, you're going to bump into more students, and you're going to bump into them more forcefully as well. So if we increase the temperature, we increase the speed of the molecules, that makes the collisions more frequent and more forceful. And what's that going to do to the rate of the reaction? We increased the collisions and we made them more forceful. That's going to increase the rate of the reaction. Here's another demo. Go ahead and watch it. We could also talk about the nature of reactants. There's a lot of examples of this. We're just going to talk about one. This is the activity series that we talked about when we're predicting products for single replacement reactions specifically. Well, another thing about the activity series is the higher it is on the activity series, the more quickly it reacts. So potassium will react more quickly than zinc, for example. This is a great video demonstration, and if you pay attention to the metals that are involved in this demo, you can see the ones that react the most vigorously are near the top of the activity series. The ones that don't have much reaction at all are fairly low on the activity series. Some of them are so low, they're not even listed here. All right, another thing that we're going to talk about is a catalyst. You probably have heard this word before, but maybe don't really know what it means. A catalyst, and I'm going to be really specific about this because if you are considering AP Chemistry, we're going to be specific with our wording here. Catalysts speed up reactions by providing a different pathway for the reaction. It's a pathway with a lower activation energy. Some people will say that it lowers the activation energy, and I can understand where they're coming from. That's kind of a simplified way of looking at it. But it doesn't actually lower the energy of the reaction, it changes the reaction. So a good analogy for this is if I were to talk about a road that goes over a mountain, that road would take quite a bit of energy to go over that road because it's going over a mountain. But if there were a tunnel path that you could go through the mountain, that would require less energy. It didn't make the other path a lower energy. It's just a different way to get there. And a catalyst is like a tunnel. It gives the reaction a different way to occur that takes less energy. For this year, it's okay for you to just think it lowers the activation energy. But if you take AP Chemistry, or when you get to college and you're taking a chemistry class, you probably need to know the difference. Anyways, here's a good demonstration of a catalyst reaction you could watch. All right, finally, increasing, and we haven't really talked a lot about this term yet, but increasing the concentration of the reactants will make it more likely for the molecules in a solution to collide. And this increases the rate of the reaction. Concentration is how many particles of reactants are in a solution. So for example, if salt water is what I'm talking about and the reactant is salt, I could pour more salt into the solution. That would increase the concentration of salt water. If you have higher concentration, there are more reactant particles moving around in the solution, so you're more likely to have a collision. That's just like if I were talking about the hallways again. We've got a fairly sparse population right now in person, and we're spread out. But let's say that we quadrupled the population that was inside the school. That would increase the number of collisions that occurred in the hallways. Same thing can be said when you increase the concentration. It's like putting more students in the hallways. You're going to increase the number of collisions, and that will increase the rate of the reaction.